For today's project, we're going to be electrical engineers and build a nightlight. Our nightlight will automatically turn off when it's bright outside, but turn on when it's nighttime.
Now that we know what we're building, let's make sure that we have all of our materials ready. Inside of our project bag, we should have 2 AA batteries, 1 AA battery holder with a switch, a mini breadboard, 2 LEDs. We're going to prefer the white LEDs, but any color is okay. A BC547 transistor. If you can see on the flat side of the transistor, it will actually say BC547. A photoresistor or light sensor. And we will also need a 68K ohm resistor and a 1K ohm resistor. The colors of these resistors might not always correspond to their resistance level, so you might need to look up a chart to know which is which. 2 10-centimeter wires and a 3-inch strip of copper tape. Once you have all of your materials ready, we can start building our project.
We're going to start with our breadboard. First, we need to orient the breadboard correctly. Place the breadboard sideways with the groove in the middle horizontal. In this orientation, the columns of the breadboard are connected. Electricity flowing into one hole will flow to all other holes in that column. However, the horizontal channel in the middle separates the top and bottom of the breadboard, so the columns are only connected halfway. For this project, we will only be using the top half of the breadboard, and you should make it clear to your students that anything plugged into the bottom will not be connected. We can also label the rows and columns, with rows labeled 1 through 5 from top to bottom, and the columns labeled 1 to 17 from left to right. Now that we understand the layout of our breadboard, we can get to building. First, we're going to plug in the black transistor with its 3 legs plugged into row 1, columns 10, 11, and 12. So I'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. And note that the round side of the transistor should be facing up. Next, insert the blue 1K ohm resistor. Some things to note about the resistors is that they may have paper pieces on the ends that you can take off, and it's hard to tell which resistor is which, so you may need to swap them later if it does not work. And also note that the direction of the resistor does not matter. Insert one leg into row 2, column 4, and the other leg into row 1, column 9. Next, we will insert the light sensor, which should have one leg placed into row 5, column 11, and the other leg placed into row 5, column 12. Note again that the direction of the light sensor also does not matter. So far, your breadboard should look like this. The next component is our LED. There are 2 LEDs provided, but only 1 is needed. The second can be used if the first is lost or broken, or if your students want to experiment to make the nightlight brighter. Here, the direction of the LED does matter. The legs are different lengths, with the longer leg being positive and the shorter leg being negative. Place the longer leg into row 2, column 9, and the shorter leg into row 2, column 10. Next, we will move on to the 68K ohm resistor. Again, it's hard to tell which resistor is which, so you may need to switch them. And remember, the direction of the resistors do not matter. Place one leg into row 5, column 4, and the other leg into row 3, column 11. Here is the final wiring for our breadboard. Next, we will attach our battery holder. Before working with the battery holder, ensure that there are no batteries inside and that the battery holder is switched off to stay safe while we connect the rest of our circuit. Next, we will connect our wires on the battery holder to our extra wires. It is common for the wires on the battery holder to become frayed, making it harder to put them into the holes on the breadboard. Attaching these small wires makes it easier to insert them into the breadboard. To connect the wires, rip off a small piece of copper tape and remove the paper backing about halfway. Use the sticky side to connect one end of the wires from the battery holder with one of the ends of the wire pieces. Note that the silver metal part of the wires should be touching and not the protective cover on the wires. Now you can fold the copper tape over the wires. Then remove the rest of the backing, and you can wrap the copper tape around and pinch it tight. Your students may struggle with the copper tape, and they may need to troubleshoot this step after the last few steps. Repeat this step with the other wire on the battery holder. Now we will connect these wires to our breadboard. The wire which is connected to the red wire originally on the battery holder should go into row 1, column 4. And the wire which is connected to the black wire originally on the battery holder should go into row 4, column 12. When connected, your final breadboard should look like this. Now we can safely insert our batteries. Remove the cover of the battery holder by sliding it forward towards the wires and removing it. It can be put back on the same way. And once we are done, we are ready to test our nightlight. To test our nightlight, first switch on the battery pack. If your room is bright, you may see nothing happening. Remember that we only want our nightlight to turn on when it's dark. To simulate nighttime, we can place our finger on top of the light sensor. Now you should see the LED can light up. If your nightlight is not working, there are a few steps we can take to fix it. Also, remember to switch off the battery pack before making any modifications. First, ensure that the batteries are inserted in the correct position. The flat side of the battery should be connected to the spring in the battery holder. The next most common problem is that one component was placed incorrectly. Check all of the components to ensure that their legs were placed into the correct holes and that the LED and transistor are oriented correctly. Also ensure that the red and black wires of the battery holder are not switched, as students sometimes get confused. Next, ensure that the wires are connected properly, with the silver metal of each wire touching the silver metal of the other wire, all wrapped inside of the copper tape. You can also pinch where the wires are connected to see if the connection is too loose. Replacing the copper tape can also help if the light still does not turn on. One final step to get your project working is to replace the LED, which may have burnt out if electricity was flowing in the incorrect direction. We now have a working nightlight, but how does it work? Like we established earlier, the columns on our breadboard are connected, allowing electricity to flow between components in the same column. This allows us to connect components to create a circuit, which allows the electrical current to flow out of the battery pack through our components and back into the battery pack at the end through a specified path. The light sensor allows more electricity to pass through it the darker it is outside, and the transistor acts as an electrical switch which only turns on when the control leg in the middle gets power. These two components determine when the light should be on. The two resistors restrict the flow of electricity to ensure that the relatively large amount of power from the two AA batteries does not damage our small components. Lastly, the LED has a small crystal inside, which lights up when electricity is passed through. In this case, only when the transistor is on and the light sensor is detecting less light. Now that you know how the nightlight works, there are a few things that you can think about with your students, such as, what would happen if we removed the resistors? What if we didn't have a transistor and instead hooked up the light sensor directly? And how could we make our night light brighter?